Hello everyone, this is a remote debugging interface. This interface displays the data of our SVG device. Its solution is to use an electric meter to sample and control the dry contact output to control the capacitor. As can be seen from the right side, we have installed a total of 7 capacitors. All of them have been put into use. Because the photovoltaic power is installed on set, the active power of the grid is very small. After the reactive power is compensated by our capacitors and SVG, the power factor remains above 0.9, and although load fluctuated, the power factor can be maintained well. Next, let's take a look at this interface. You can see the data on the meter. The line voltage is 10,000 volts and the current is very small. Because it is a photovoltaic set, its active power is basically offset by photovoltaics. And we can see that its total active power is very low and fluctuates, and the total reactive power also fluctuates. This fluctuation is caused by the load, and our equipment can control it. The lower right corner is our compensated power factor. Okay, this is our debugging interface. In this interface, we can see the remote function debugging parameters. With the value fluctuates, we can see that PI is changing. Okay, this is the control part of the whole closed loop. Okay, let's see the next interface. In the capacitor switching interface, we can see the capacitor settings. This site uses 7 capacitors. The power factor is set to 0.95. The capacitor switching threshold is 50%, and the waiting time is 15 seconds. These two values mean that when the load rate of the SVG exceeds 50% of its capacity and lasts for 15 seconds, a new capacitor will be added. So when will the capacitors be removed? When the SVG output is inductive and the output capacity is 50% greater than its capacity and lasts for 30 seconds, the capacitors will be removed. Okay, this is the operation interface. You can see that the load is fluctuating rapidly. However, the power factor is still maintained relatively well. Okay, this is the situation on set, a case where SVG plus capacitors are mixed. SVG is used to control the capacitors, and the meter is placed on the high voltage side for measurement and sampling. Okay, that's all. Thank you.